Bismillah, this is Dr. Magda Talib Al-Hinai from Department of Mathematics and Statistics, Sultan Qaboos University, presenting logarithmic functions. This presentation is exclusive for the Independent Learning Center at Sultan Qaboos University. We start with the definition of logarithmic functions. Logarithmic functions to the base a, where a is greater than 0 and not 1. This is defined by log x base a is equal to y, it's equivalent to x is equal to a power y. In other words, log x base a is the exponents to which the base a needs to be raised to give x. Note, the logarithmic function log x to the base a is the inverse of the exponential function a power x. The graph of the logarithmic function, as we said, log x to the base a is the inverse of a power x. So, the graph of log x to the base a is the mirror reflection of the graph of a power x in the line y is equal to x. We see that the domain of the logarithmic function is the open interval from 0 to infinity, while the range is all real numbers. Logarithmic functions are one-to-one and onto. Here we give you an example. We ask you to graph both 2 power x and log x base 2. Again, we see the mirror reflection of 2 power x in the line y equals to x. This gives us log x to the base 2. Example, use the graph of log x base 2 to sketch each of log x base 2 plus 3 and log x plus 3 to the base 2. Okay, we start with the graph of log x to the base 2, and then we shifted vertically upwards 3 units. This will give us the graph of g of x, which is log x base 2 plus 3. While for h of x, we see that the x plus 3 means a horizontal shift to the left 3 units. So, shifting the graph of log x to the base 2 to the left 3 units will give us the graph of h of x, which is equal to log x plus 3 to the base 2. Properties of logarithmic functions. The first property, log xy to the base a is equal to log x to the base a plus log y to the base a. The second property, log x over y to the base a. This is equal to log x to the base a minus log y to the base a. Property number 3, log x power c to the base a. This is equal to c log x to the base a. Property number 4, log a power x to the base a is equal to x. Property number 5, a power log x to the base a is equal to x. Property number 6, log a to the base a is equal to 1. And property number 7, log 1 to the base a is 0. Example, without using calculator, find the value of a log 32 to the base 2 plus log 4 to the base 2. We know that 32 is 2 power 5, so we replace 32 by 2 power 5. We have log 2 power 5 to the base 2, and we replace 4 by 2 squared, so we have log 2 squared to the base 2. Now we apply the properties of logarithms and we put the exponents down, so we have 5 log 2 base 2 plus 2 log 2 base 2. Here we have log 2 base 2 means 1. So I have 5 times 1 plus 2 times 1, this is 7. For part B, we're asked to find the value of log 1 over 25 to the base 5. 25 is 5 squared and it is in the denominator, so we replace it by 5 power minus 2. So we are now calculating log 5 power minus 2 to the base 5. Again, we use the properties of the logarithms and we put the minus 2 in the exponent down. So we have minus 2 log 5 base 5, so this is equal to minus 2. Now we deal with natural logarithmic functions. Natural logarithmic functions are functions with the base e. And we don't write log x to the base e, we simply write ln x, ln x. So ln x is equal to y. This is equivalent to saying x is equal to e power y. In other words, ln x is the exponent to which the base e needs to be raised to give x. And we note also that natural logarithmic functions ln x is the inverse of the exponential function e power x. The graph of the natural logarithmic function is given by, here we have e power x and the mirror reflection ln of x. So these two curves are a function and its inverse, and it's a mirror reflection in the line y equals to x. The domain of the natural logarithmic function, as we see, is from 0 to infinity, while the range is all real numbers. These functions are also one-to-one and onto. Here we have the properties of the natural logarithms in front of us. We don't need to repeat them. You have a look at them. Example, find the domain of the function f of x is equal to ln of 3x minus 9. So the domain, as we know, should be anything which makes 3x minus 9 greater than 0. Adding 9 to both sides, we have 3x is greater than 9. Now, dividing both sides of the inequality by 3, we get x greater than 3. So the domain of the given function is the open interval from 3 to infinity. And here comes common logarithms. The common logarithmic function with the base 10 is defined by log x equals y. This is equivalent to x is equal to 10 power y. Notice that we don't write the base, we only write log x, we don't write to the base 10, and we know that this means log x to the base 10. And we also say that log x is the exponent to which the base 10 needs to be raised to give x. Clearly, common logarithmic function log x is the inverse of the exponential function 10 power x. Here we see the graph of the common logarithmic function log x and its inverse 10 power x. The domain of the common logarithmic function also is from 0 to infinity, while the range is all real numbers, and this function is a one-to-one and onto function. Here we also see properties of common logarithm. You can go through them, we don't need to say them. They are all the same as the properties of the logarithmic function log x to the base a. Here we have an example. Without using calculator, find the value of log 100 plus log 1 over 100. We all know that 100 is 10 squared, so we write log 100 plus log 1 over 100. This is equal to log 10 squared plus log 10 power minus 2. And we apply the properties of logarithms to put the exponent down. So we have 2 log 10 minus 2 log 10. This is 2 minus 2, this is 0. The second part of the question, find log square root of 10 minus log 10 power minus 7. Square root of 10 can be written in the form of 10 power half. So here we have log 10 power half minus log 10 power minus 7. And again, we apply the properties of logarithms to put the exponents down. So here I have half log 10 minus 7 log 10. Log 10 is 1, so I have half times 1 plus 7 times 1. This is equal to half plus 7, which is equal to 15 over 2.